Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. The date for today is January 7, 2025, and the time is 22:46. That's military time. 22:46 minus 12, that will be 10:46 p.m. Okay, my topic for this evening will be a continuation of my long video format topic on my mathematics section. This is analytic geometry, and I am now on lesson number 21. Lesson number 21 is actually a continuation of the topic on ellipse, and since the last time around, I have given you the first example problem on the concept of ellipse. So for tonight, I will be discussing example number 2. This will be the second example maybe, before we will proceed with the so-called study of circle. Okay, let's proceed. I will try to check my camera. Oh, it looks fine. The subject matter for this evening will be a long video format topic on my mathematics section of my channel, and this is analytic geometry lesson number 21, and the title of the topic will be ellipse example problem number 2. Okay, I will try to give you example problem number 2, that is with regard to the study of ellipse. Okay, I will try to read the problem. Find the equation of an ellipse with center at the origin. Eccentricity is equal to 3/5. One end point of the minor axis, the smaller one, the shorter one. One end point is at the location -8 and 0. The problem is asking what will be the equation. So if we try to recall the equation of an ellipse with center at 0, 0, there are two variations. That is, okay, I will try to use the black pen. Black pen. The first one is x squared over a squared plus y squared over b squared equal to 1. And the second one will be x squared over b squared plus y squared over a squared, and this should be equal to 1. The problem is asking what will be the required equation with the given condition. Okay, I think we will be using this equation here. That is an equation of an ellipse in which the major axis is along the y-axis. Because if we try to figure out the problem, this will be the figure. Don't worry guys, my ellipse looks like a circle, but it's not a circle. This should be the major axis, and this is the minor axis. It just so happened that I make the minor axis a little bit almost same, but they are supposed to be different. With the figure, it is something like this. One end point of the minor axis is at the location -8 and 0. This is the first end point. This is the minor axis. So if the minor axis actually coincides with the x-axis, the major axis is the reverse of that one. So like what I said, the major axis is along the y-axis. So we will be finding the equation of this, or we will be using this equation here. So our only problem now to solve for the equation is we must have to solve for the value of the major axis, and we must have to solve for the value of the semi-minor axis. Anyway, the ellipse is actually, the center is actually at the origin. Okay, so this is actually just simply x squared, and this is y squared. Okay, So to compute for the equation, we must have to compute for A and to compute for B. Then we'll place these two values back here, and we could now bring out the equation of the required ellipse. This is the given figure, right, for an ellipse. Okay, we try to recall the relation of the value ABC, the relation of the semi-major axis, semi-minor axis, and the value C. The value C is actually where's the value C? The distance from focus to center is actually C. Okay? And this A here is the semi-major axis, and this B here is the semi-major axis. And there is a relation of this A, B, and C for an ellipse. Okay, let's try to bring out the solution. Okay, I will try to check again my camera. If it's still working, it's still working. Let's try to bring out the solution. Eccentricity, the given eccentricity is actually 3/5. Okay, and for an ellipse, the formula on how to compute for the eccentricity is given by this equation here, that is eccentricity E is actually the ratio C/A. This C here and this E here. That's the formula on how to compute for the eccentricity for an ellipse. Eccentricity for an ellipse is actually the ratio C/A. Okay. By inspection, B is actually the semi-minor axis, and actually we could now bring out, or we don't even have to compute for the value of the semi-minor axis. It is actually given, and we could do that by inspection. Since the endpoints of the semi-minor axis, one of the endpoints is at -8 and 0, the opposite of this will be in the other side. So the other endpoint will be at the location 8 and 0. And one half of this is actually B, and this is B. So now, by inspection, the value of B is actually 8 units. Okay? So we are now given this one to be 8 units. So our only problem now is the value of A, so we could compute for the equation. Okay? I place it here. Major axis is parallel to the y-axis. Parallel to the y-axis. Why parallel? Because this is the semi-minor axis, and the opposite of this is the one that goes up and goes down, and this is the major axis. From the center up to this endpoint here, the coordinates is actually 0 and A. And this here is the major axis. Okay? And going below, it is symmetrical. It should be this, what they call this, the coordinate of this will be 0 and -A. -A because it is downward. Right? So we go back to this equation here. This should be the required equation. We now know the value of B. B is actually 8 units, so this is actually over 64. So our only problem now to compute for the equation is we must have to compute for the value of A squared, or we must have to compute for A. And where do we get the value of A? Okay, let's try to bring up the computation of the value of A. Since eccentricity for an ellipse is C/A, it is C/A. The given eccentricity is 3/5. So this is 3/5. And that is eccentricity. We could erase this one now. So in here, we are given the relation C and A, and that will be equal to 3/5. Computing for C, C will be the product of 3/5 times A. We call that equation number 1. Am I still on camera? Okay, I am now on camera. Okay, that will be equation number 1. And using the relation E squared equal to B squared plus C squared for an ellipse, this one here emanates from this one. If this is B, and this is C, and this is A, and this is a 90 degree, we use Pythagorean theorem. The square of A should be equal to the summation of the square of B plus the square of C. That's where we got this one. Okay? We call this equation number 2. We will get the value of C to be equal to 3/5 A. We will substitute this one to equation number 2. So the left hand side will be A squared. The right hand side will be equal to the square of B, but B is actually 8 units. So this is H squared plus the value of C in terms of A, which is 3/5 times A quantity squared. Squaring this one, the square of A will be A squared. Okay, I transpose the square of this one. 3 square is 9, 5 square is 25, A square is simply A square. I put it on the left, so this is now minus. And this should be equal to the square of H square. That will be equal to 64. The denominator of this one is 1. The denominator of this one is 1. So to eliminate this 25 here, we must have to multiply all this 1 by 25. Right? So A square over 1 times 25 will be 25A square. 9 over 25A square times 25, this 25 here, cancel with this. So what remains is 9A square. And this should be equal to 64 over 1 times 25 will just be simply 64 times 25. We combine similar terms, A square on the right hand side, 25 minus 9, that will be 16A square, equal to the product of 64 times 25. And to eliminate the 16 on the left, we will multiply both sides by 1 over 16. So 16A square times 1 over 16, this 16 here, cancel with this. What remains will be A square. For the right hand side, 64 times 25 times 1 over 16, it will still be 64 times 25 over 16. And luckily this 16 here, cancel with this will become 4. So A square will be the product of 4 times 25, or A square is equal to 100. And to compute for A, we must have to raise both sides to the 1/2. Okay? A square raised to the 1/2, these two here cancel with this. What remains is A. And 100 to the 1/2 is the square root of 1/2, or 100 rather. And the square root of 100, it's a positive real number. It should be a plus or minus. Okay? We are computing for a positive right number, so we will disregard the negative 10, and we will use the value of A to be 10 units. So if we try to go back to this equation here, this A square here will be a 10 quantity square. And if we try to simplify, x square over 64, the resulting equation now will be x square over 64 plus y square over A square. A square is 100, and this should be equal to 1. So this will be the answer. This is the required equation of an ellipse with center at 0, 0, and which one endpoint is at -0, -8 and 0, and the value of the eccentricity is 3/5. This is the required equation. X square over 64 plus y square over 100, and this should be equal to 1. Okay, that's it guys. So for those of you who would like to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. For those of you who don't know yet the contents of my channel contains long video format topics. I uploaded 10 subjects already, complete syllabus. So for those of you who would like to take up engineering, this is for you guys. And on my short videos is a combination of mathematics, electronics, and some other things. That's for the short videos. But the concentration of my channel is actually on the long videos, because for as long as we are living here in this world, the concept on the long videos will not change. Okay, good evening from Los Angeles. This is Professor David J.